Hello and welcome to this quick presentation about the war of the roofs, as I call it. So it's the question, what is better when you have a heat pump? Is it solar thermal on the roof or is it photovoltaic? Is it PV on the roof? A question that we get asked quite a lot from customers and installers, and we have the answers for that question. So I will try to explain that in a very technical way in these couple of minutes. I decided to do a quick voiceover for the German presentation with English sound. So the text will be in German, but I will explain. So what you see here first is the statistics from Switzerland, from the Swiss solar market. We see here solar thermal collectors, flat plate collectors, and there was a quite big market in 2010, 2011, 12, where they sold thousands of square meters of solar thermal panels. But since a couple of years, these numbers were getting smaller and smaller. On the right-hand side, you see actually what is produced by these solar installations, solar thermal installations here in Switzerland, and it's 739 gigawatt hours that are produced with solar thermal installations. So it's not just flat plate, it's also vacuum tubes and some other collectors that are available. 739 gigawatt hours. On the other side, these are the numbers for PV. So what did happen in the last 20 years is a long time there was nothing actually happening, and when the prices started to get a little bit better for the customers, the market steadily has grown and more or less exploded in the last years for PV. So you see there on the right hand side here on this slide what is actually produced with PV. So it's 2,600 gigawatt hours that is produced with solar PV. Is that a lot? It's quite remarkable, but it's still not enough. So it's just 5% of the consumption of Switzerland is actually produced by solar PV. So it's still a long way ahead for us. But you see a little bit the relations here. PV is producing multiple times the energy of solar thermal right now in Switzerland, and this is gonna go further like this in the next years. What is my experience with solar? I'm very lucky to have a couple of solar installations on my roof. So the first 4 years I had vacuum tubes for hot water production. So it's like a 250-liter hot water tank in the basement somewhere. And it's the first 4 years, as I said, it's 3.2 square meters of vacuum tube on the roof. Then after those 4 years, I decided to go flat plate, which you see on the right picture, which looks a little bit odd. So not the most aesthetic way to do solar, I would say. But the motivation was I want to get more solar power. So I made the surface of the solar collector bigger and put it on the roof. What I achieved was roughly 60% of coverage. So the demand for domestic hot water and my washing machine, it's also connected to the hot water tank, by the way, I could cover to 60%. So that means 40% were boosted with electrical resisting elements or a little bit with the heat pump. So just 60% were covered. The figures, numbers were just over those 12 years, the average yield for solar thermal was 530 kilowatt hours per square meter. Solar collector end year, 530. Okay. A little bit of maintenance was necessary as well. So I had to change the glycol once because the vacuum tubes are quite hot, they're running hot, and the glycol was actually burned. So I had to replace the glycol. And also had a little bit of air in the system from time to time. So you need to bleed the system every 2 years. But it's probably just a little bit the situation that I have with my solar system is a bit special. But as I said, after 12 years, I decided to go PV. So de-installed the solar thermal installation and installed solar PV. Actually, the circulation pump of the solar thermal system was broken. I didn't replace it. Was actually the tipping point for my decision to go solar PV. What you also see on this slide here down there is a graph where you see the typical coverage for a small solar system in Switzerland, like a domestic system, 5 square meter, a 300-liter hot water tank, and you will achieve with this design 60, maybe 70% of coverage. So you need still a little bit of boosting. You will not design systems for 100% coverage, because then you will have to oversize them quite a lot. And oversizing means expensive systems, and also overheating problems in summer can happen. So that the sweet spot for solar thermal systems will be like 60 to 70% coverage in Switzerland. Anyway, then I switched to solar PV. 2019. First, I just put some panels flat on the garage roof, as you see here on the left-hand side. The problem here is we have snow from time to time, couple of days maybe, and if there is snow on the panels, on the PV panels, there's no electricity coming. So that's not really ideal. That's why I put some other modules, PV modules on the roof. So they are producing a little bit more energy during the year. What I also have is a heat pump for domestic hot water and a heat pump for heating and cooling, passive cooling. It's a geothermal heat pump. And they run in energy management. So there is communication between solar, PV, and the heat pumps. So typically, if I have a little bit of excess power from solar, then the heat pump switches on, or the switch with the heat pump goes to a higher temperature level typically. Okay, what did I achieve the first year? It was 5,000 kilowatt hours of solar yield, and self-consumption was at 51%. So I could use 2,500 kilowatt hours, a little bit more than that, for myself. In last June, I decided to go a little bit bigger. So I added these 5 modules on the roof, which added 2 kilowatt peak to a total of 7.2 kilowatt peak. My yield now is around about 7,000 kilowatt hours a year. Now I want to know how much is the yield per square meter. Is that really relevant? In my case, I would say not really, because the roof is completely covered with solar PV on the garage, but you actually can't see the solar install. It's invisible. If you approach the house, you can't see the solar install. And for me, it's not super relevant in an aesthetic kind of way. It's really not relevant. So I just made the garage roof completely full with solar PV. But here in my case, the total is 31.8 square meters. And I want to know how much this is the solar yield per square meter compared to solar thermal. In my case here, I can achieve 220 kilowatt hours per square meter and year per solar PV panel. 220, which is just 41% of what solar thermal can do in my case, in my situation. So actually, 1 square meter of solar thermal can do more than double than 1 square meter of solar PV. But I work for Stiebel Eltron. We are doing heat pump systems for domestic hot water and heat pumps and heating systems. So we talk about COPs. That's the coefficient of performance, the efficiency of a heat pump system. In my case, some numbers for heating, it's COP of 6.5. So I achieve 6.5, and for domestic hot water, it's like 3 to 3.5. When I do the numbers here, I know from the relations that my heat pump needs to have a COP of minimum 2.4 to have the same efficiency like solar thermal. It's really just the heat pump that is the game changer. It lifts up the energy from solar PV with the COP to a higher level. As I said, I need 2.4 to be equal with solar thermal, but I achieve 3.5 with domestic hot water and 6.5 for heating. So way more efficient. What technical troubles did I have so far? Nothing. Knock on wood. It's just solar PV is quite easy now. It's just a bunch of cables. You have everything on your mobile phone, on your app. You have very good connectivity to other systems, energy management software. It's really fun. Also, it's a great hobby for me as well. So now if you have solar PV and you think about a hot water solution, maybe you have a electrical uh, hot water tank or gas hot water tank, something like this, then you could use a domestic hot water heat pump. In this case, it's a WWK from Stiebel Eltron, which is in my basement, and I give you some rough numbers. So these heat pumps nowadays, they have special terminals for smart grid ready. So they can actually take signals from your PV system. You have two values for temperature. One is guaranteeing you that you have a warm shower in the morning, and the second one is that you can make the heat pump run longer on solar PV electricity. I use around about 3 kilowatt hours a day for domestic hot water. So it's for 4 persons, for people and the washing machine, 3 kilowatt hours. The machine by itself, the heat pump uses 400 to 550 watts in operation. Two-thirds over the year, I run it completely with PV in my case. There's no general number here, to be honest, because every PV system is a bit different, climate is different, and hot water consumption is different as well. In my case, it's two-thirds over the year. What is the COP? It's calculated, it's not measured, between 3 and 3.5. What is also important is to mention that if you put your WWK in the basement somewhere, it's going to really cool down your environment there. So it's quite important that you have some insulation between your warm part of the house and the cold part of your house. So you need some insulation there. Otherwise, you're going to steal energy from your heated environment. That's pretty important. But again, 3 kilowatt hours consumption, two-thirds of that is coming from solar PV, which in my case is like 13 cents per kilowatt hour that I have to pay for solar produced PV electricity. So it's super cheap. It's like 30 to 40 cents a day for domestic hot water. It's nothing. Then I decided to create a little bit of calculation in form of an Excel spreadsheet here. So I wanted to compare side to side hot water heat pump and solar thermal. So just for my case and my numbers that I have measured, we are 4 people. It's like 50 liters per person and day. The heat pump needs to heat up 50 Kelvin from 10 to 60. And the COP is 3.5, which might look a little bit high, but it's actually measured. And if it's 3, it's still not big of a deal. It's not a big change to solar thermal, as you will see right now. So, but when I just calculate the numbers here, the energy input for domestic hot water is 4,000 kilowatt hours. That's what I need in energy for my hot water. On the other hand, the heat pump just uses 1100, 1200 kilowatt hours a year to do that. So I save 3000 kilowatt hours. They are coming from the environment, from the air. What can I do with these 3000 kilowatt hours per year? I can drive an electric car, for example. If I have an electrical hot water system, 3000 kilowatt hours will give you 15,000 kilometers of electrical car driving. So that's really just also a good comparison. Let's go further here. So if I need those 1167 kilowatt hours a year in electricity, if I want to produce that with solar PV, how big has the install to be? So just my numbers, using my numbers, my measured numbers, I end up with a solar PV system with 1.2 kilowatt peak. And if I use some good PV modules elements, then I need 5.3 square meters of solar PV on my roof. The funny thing is, if I do the same thing with solar thermal, it's actually the same surface on the roof. So a typical domestic 4, 5, 6 person system will also use 5 to maybe 6 square meters of solar elements on the roof, solar thermal elements. But now is the big game changer here as well. These systems are calculated, designed and built to cover 60 to maybe 70%. So in winter, cloudy days, rainy days, you need to boost the hot water with gas, electricity, heat pump, oil, whatever. So you need a second heat source. To cover those 40% that are not covered with solar, so you end up with 1630 kilowatt hours that you need to boost. And it's not unusual to do that electrically with an element or so. If you want to cover that with PV now, the rest, you end up with a bigger PV system than for the whole hot water heat pump system. And I think that's quite unusual. So when you do the numbers, 1.2 square meter PV system for the hot water heat pump and 1.7 plus 5.3 plus 5.4 square meters of solar thermal to do the same thing. So it's quite clear in which direction we are heading. Often it's just compared by efficiency numbers, and I think that's correct. So if you just do the comparison between a solar PV module and a flat plate, a good flat plate collector, it's pretty obvious then that the solar system is more efficient, the solar thermal system, but you have the heat pump as a game changer. Okay, just want to give you an impression of what's happening typically during a day when you have a little bit of sun coming. This is a 5 kilowatt system in my house, and you see during nighttime there's also a little bit of standby operation of some computer network stuff or fridges and things that are running. But here in my case at 6 o'clock the sun starts to go up, and you also see here the blue stuff, that's the consumption. At maybe 8 o'clock in the morning there's a small step up here a little bit, and that's actually the domestic heat pump that switches in. Here at 6 o'clock, that's the coffee machine switching on, but here at 8 o'clock, it's the domestic hot water system that goes into operation. And it goes further and further. Here, this big blue part is actually going into the EV battery, giving me more range. So this is controlled by energy management system software. Some numbers, my house here. So you see domestic hot water is quite important, but it's not the biggest consumption, to be honest. It will be the biggest consumption without heat pump, to be honest. But it's the biggest one is the electric car. Second biggest is heating and cooling, and then is domestic hot water. So we also need to integrate holistic solutions that include also car charging. Okay, that's it. Just wanted to add an English speaking version for this presentation because I got a couple of questions. And I hope you enjoyed that presentation. Please write me your questions if you have further questions in the same direction about heat pumps, solar, energy management. I'm happy to answer the questions, to respond to them, and also looking forward to have some discussions with you. Other opinions can be possible as well. But until then, thank you for listening and bye bye.